Okay, so in this video we're going to expand ourselves from just talking about a single term function to multiple term functions like this polynomial here. And so in the notes, hopefully you've read through the fact that derivatives are allowed to distribute across addition and subtraction. And so as we work through this derivative of 7x cubed minus 5x squared plus 12, we're going to first, as we start doing our derivative here, realize that derivatives distribute across addition and subtraction, and additionally we can pull constants outside of the derivative process. So when I come to that 7x cubed, I can pull the 7 out, and it'll be 7 times the derivative of x to the third. Minus, pull the 5 out, times the derivative of x squared. Plus the derivative of 12. Now, I want to encourage you, as you're doing the first couple of examples, to go through slavishly putting down detail. And the reason I say that is some of you might kind of thinking, that's a lot to write right now. I can do that without writing all that down, and I'm sure you can. And we will do that later. But I really encourage you to write out that extra detail to give yourself that time to let your mind really digest what's going on and make that connection. Writing it out really makes you think through it and helps you to make that connection so that later on when you do cut out some of the details, you'll be all right. You'll be fine. You'll be less likely to make mistakes. Whereas if you kind of jump to try to do everything from start to finish in your head without any detail, then you're going to start maybe missing some connections. Or later on when you look back at it, you're going to be like, how did I do that? So I really encourage you early on here to write out some of the details. And so that's what we've done here. And so we continue here. Derivative of x cubed, we multiply by the exponent, drop it by 1. So it'll be 7 times 3x squared. And then minus 5. And then the derivative of x to the third, x squared, multiply by 2, decrease it by 1. Plus the derivative of 12, which is 0. And then we just clean that up and we have our answer. 21x squared minus 10x. So the derivative of f of x equals 7x to the third minus 5x squared plus 12 is 21x squared minus 10x. 21x squared minus 10x. Let's consider a second example. This time we have a fractional function, a function involving fractions. Well, much like we did earlier when we had a single fraction, we had to rewrite that as a power of x. So we're going to have to rewrite those two terms as powers of x. So we can write that as 12x to the negative third plus 9x to the negative fourth. Now they're expressed as powers of x, so we're ready to use our power rule. So once again here we begin f prime of x equals, I'm going to write out the detail. That's going to be 12 times the derivative of x to the negative third plus 9 times the derivative of x to the negative fourth. Okay, and we go through and we invoke our power rule. So 12, and then we do the derivative of x to the negative third. We would multiply by the exponent. So 12 times negative 3, and we drop the exponent by 1. Plus 9, derivative of x to the negative fourth, we multiply by the exponent, drop the exponent by 1. And then we just need to clean this up. 12 and negative 3 would be negative 36. X to the negative fourth is going to need to go to the bottom. So we'll have 36 over x to the fourth. And then 9 and negative 4 would be another negative 36. X to the negative fifth will go to the bottom, so that'll be minus 36 over x to the fifth. 36 over x to the fifth. And so now we've done some derivatives. And that answer is fine. In the next video, I'm actually going to step you through how to simplify that. There's another way to write that. We can, of course, add those fractions by getting a common denominator. But I'm going to show you another way to simplify that expression in the next video.